Following this train of thought of my predecessor, I will talk today about science and art and how they can inspire each other. Using the examples of mutual, what we call mutual inspiration or influence. And we will try to define the topic from different sides, from a side of what art can do for science and the other way around, meaning what science is doing and can do for art now and in future. I am just replacing Professor Alicja Rafalska-Łasocha today, and I will try to do my best to show you what she was trying to say through this lecture. But before we start, I think that we need to define what we mean today by science and what we mean today by art, just to know the words we are using. And we'll also think what kind of synergy we can take out of on the verge of both, I would call, disciplines. One colleague once told me that the best lecture should start with Aristotle. So I am following his teaching. I will start from him because I may say that everything, this division into art and science that we all experience today, dates back to Aristotle, who simply introduced this division into science. We may call him a founder of a modern science. It goes without saying. Aristotle introduced into science, into philosophy at that time, two terms, episteme and techne. Episteme, well, putting it into a simple language, episteme is something which we can think of, which we can understand. Techne is understood as something we can produce, we can do with our hands. So that time, art was understood in such a way that this was something that we can do with our hands. So then this technique converted into modern technology and art developed in some other way. But in fact, what we understand today by science is just the methodology, is the method of science, which is based on observations which we collect. Then out of those observations, we try to conclude some models or theories, and we test those theories through other observations. So this goes in a kind of a circle, observation and modeling, observation, modeling, observation, experiment, test, is testing the models, and the models put the questions which are checked by the experiments. At modern science, I may say that it goes like that, in such a circle. And well, but what is art and how we can use it? Art is everything, well, everything which is behind that, everything which we can think, which is more than that, which is not described by a scientific method. Art is for our inspiration, for touching our senses, for touching our emotions. So the definition of art is not very clear, but definitely everything which goes beyond our understanding and moves us and inspire us and opens us, we may call art. So art, I may say, is more like a open term, and more today maybe more inspiring, but we shall see what is the mutual inspiration in the next, I hope, slides. Trying to put some systematics on what I'm trying to say, which is in fact part of our project, which we'd like to introduce into different programs in Europe, which is entitled like that. I put this presentation into two parts. I divide it into two parts. One will be connected with what art can do for scientists, and the other part will be just devoted into the other question, which is analogical, but its focus is on science and its influence on art. I will use as an example today a picture which I am still hiding to you. The picture was shown, the paintings was shown on the exhibition in the year 2006 at the Jagiellonian University Museum, which is shown on the lower part of the slide. This is one of the oldest buildings in Europe because our university was founded as one of the first, except Padua and Bologna University in Bologna, universities in Europe. And you have some pieces of history about our university. So in this, the oldest building, the exhibition I'm talking about was prepared and shown to the public. The title of this exhibition was Scholar and His Study. One of the paintings which is shown on this exhibition was the painting I am showing to you right now. And well, the first question to you is just to ascertain, to be aware what we see in this picture. Well, this is so-called group portrait, and in a first plan of this, what we see just straightforward in this picture is a group of three men. Well, maybe judging by the appearance, the two of them are priests and one is just we don't know who yet, but he has supported his arm on a book, so maybe he's a scientist. Well, this is the presumption, but we can judge also from these pictures that maybe this is somehow connected with science. And during the exhibition I'm talking about, no one that time knew what was the scene, in fact, that is presented by these paintings. So we see a group of men, probably one is an educated person, the other are priests, and the two men are some kind of show astonishment, we may say. There is another little person, perhaps an assistant, a little boy, who is holding a flask, some kind of a container, probably in his hands. And what another striking thing in this picture is the light. Look at the light. The light is blue. So the whole picture is glowing, as if glowing in blue. So where does this light come from? This is the first question. We may also say that on the background of this paintings, there is some kind of a lab. There are flasks. There are some chemical instruments. Maybe someone was there in a lab and was astonished by a discovery, by something. We may only think of, well, just presume that this is something connected with the discovery. So let's do a little investigation into what is in this picture and what this picture is trying to tell us. But before we go further on, I just will try to stick to a main train of this lecture and show you some striking examples, most important examples Alicia discovered in the history of art and science. And these are just strong connections between, these examples show strong connections between artists and scientists, which are shown in this picture. Yeah. Another pictures which are also present, paintings which are also present in this exhibition, was just the paintings, the title of whole exhibition was taken from, and the Alchemist Workshop, another paintings. And I'm showing this because I would like to take a little bit of alchemy, which was just the beginning of modern chemistry I am representing the subject of today. So let's come back to this painting. The painting was created by a painter who lived in 17th, Dutch artist who lived in 17th century, Cornelis de Man. So another question we should ask ourselves, what event, maybe some important event in the history of science, was shown in this picture? To answer this, we have to look at the 17th century and the history of science and the development of mankind thought at that time. So talking of 17th century and the history of science, we have to mention Descartes, a famous philosopher. Due to, I may say, maybe that's some kind of a shortcut, but that is due to him that the science started to develop since 17th century. He introduced into philosophy two different realms. The people, the scientists could recognize in reality. One was matter and the other was spirit. Due to the fascination of clocks, which took place, the clocks were developed in the 17th century, that goes without saying. The matter, the materialistic world, was compared to a machine, to machinery, which can be described and understood. And this is what, in fact, science, modern chemistry, modern physics does. It treats matter as an independent realm, independent domain, which can be described and understood. Whereas soul is a domain for church, for religion. This division, in fact, was very important to the development of science because due to it, the science could develop without the influence of some exoteric approaches, could develop in some simple way. And what we have right now is just a result of it. So because matter was something which we can understand, people were trying to just to compare matter, to compare universe to the machinery. And what we have right now. And answering the question, what was shown in this picture about the man is just the discovery of one of the elements, which was very important. On the right hand side, you have another picture talking about the same event, which was painted on a picture which we are trying to describe right now. This is the discovery of phosphorus. Now we know that phosphorus is able to emit light, which we call luminescence. The discovery of phosphorus was due to Brandt, who in fact wasn't a scientist. He was, for sure, he was an alchemist who was trying to find some methods of transformation of different metals to golds. This is what that time alchemists were trying to do, as if neglecting the origin of alchemy, which was transferring the spirit or the soul into better kind of attitude towards life. We may also find such a short description of alchemy in terms of transmutation of souls. But that time, alchemists were devoted into finding a philosophical stone which would convert any metal into gold. But the rumor that time, the rumor also said that urine can be transmuted into liquor. So some of the alchemists were trying to do the experiments that would allow to obtain more liquor, which could be sold, and in that way they could earn some more money. Henning Brandt was also doing such an experiment. So in oxygenless atmosphere, maybe not oxygenless, but well, today when I think of it, perhaps this is not quite done in oxygenless atmosphere, but he was heating the urine for some time, evaporating water, and well, after some days of evaporating water and heating the solid, which would stay after evaporization, he noticed that this solid can glow, producing such a blue light. In the beginning, no one understood what was that time they call it substance, what was the material obtained out of it. But then the discovery was noted in science as a discovery of phosphorus, which spontaneously emits light. Brandt, of course, earned some money out of this discovery because he kept this discovery, this method, this protocol that he used to obtain phosphorus included in the urine. He kept it as a secret, so he sold some of the samples to other people who also were trying to make some money out of this discovery. And well, there are some shows also presented to the king that time as a, well, entertainment more than a discovery. Brandt had a lot of followers from that time who were trying also to obtain phosphorus using this protocol, which was later on or sooner simply uncovered by his predecessors. And well, we may mention also among them, we may mention also Isaac Newton, probably the biggest scientist from that time. Although Leibniz was called the person who knew everything that was well discovered and known at the time. So when we try to conclude what art can do for science using this example, I may say that definitely art can register was able to register and was used as a registration method that time to write about history of art. But the question stays open: what art can do for science today? I think that art can, due to its openness, due to its unlimitation in any domain that it is touching, it can be used as inspiration, as a method of finding motivation and some kind of a driving force for scientists to be more creative, I may say, simply more creative. This is sometimes something this is perhaps the most important thing that happens to scientists after many years of dealing with science, to find a method to stay creative, to be more creative. Let's shift into another question. This is what science can do for art. This is already happening in the realm of chemistry, and it is kind of abbreviated in the new term that appeared in science that is called heritage science. Heritage science uses modern methods of analyzing matter to the objects of art, of archaeology, of history also, just to help in three different areas. One is the question of conservation of artifacts, conservation of archives, which is connected straightforward with degradation of materials. This is what happens spontaneously, as you probably all know, to all materials. And that is connected with the chemical phenomena that took place between different ingredients, not only chemical, but also physical phenomena. We cannot neglect that. Whose result is just the damage or deterioration of artifacts. Another area is just the authentication, because there are great many examples of forgeries in the history of art. So science may help and is helping in this area as well. And finally, to aid another areas and other disciplines of science and history, that is archaeology or history, to help dating, for example, to help finding the content of the materials found by archaeology, to help further to understand the events that took place in history. But when we look at the objects which are connected with history or art, we simply find, on the one hand, books, paintings, frescoes. This means that we deal with stones, different kinds of minerals, with glass, with textiles, fabrics, ceramics. This means that, in fact, we deal with materials which can be described by chemistry and physics. So what is heritage science about? It's about solids which can be studied using modern methods of analysis, and the models which were developed for other similar materials. This is just a picture to show you different kind of modern analytical methods that we use in chemistry and in physics. You have the pictures and abbreviations that we use also to describe the materials in the examples I would like to show you in the next part of this presentation. I will share with you the work by Professor Rafalska-Łasocha and Professor Łasocha, Professor Rafalska is the author of this lecture. I'm only showing, and they did the X-ray diffraction measurements of different, a vast array of different paintings for the sake of analysis of the pigments that are included there. So you may ask the question, why analyzing the pigments? Why we need to know what is the painting made of? Well, to prevent the mistakes, conservation mistakes, because well, I hope that all conservators today agree that we need to use the achievement of modern science, of material chemistry, material physics, engineering, to avoid mistakes in conservation or restoration of the artifacts. The striking example of mistakes are the rolls from Qumran. Probably you know the story. Well, on the rolls of Qumran, I think the most important history of Christianity is written. They tell the story from the beginning of our era, let's say. And the first mistake which was done to these precious pieces of history and written evidence of our history as a mankind was the lamination. Well, lamination just cut off the pathways of oxygen and water into these rolls. And the effect was blackening to such an extent that the precious rolls were very hard to read, or they couldn't be read at all, and they also were torn into pieces. So decision on lamination was wrong because it accelerated degradation. So the reason for which we have to know what is inside the artifact, painting, is just to make reason-based decisions on the conservation. So chemistry is trying and is doing it for decades right now, but is trying to aid conservators with their decision on conservation. And here I'm showing you just the results of X-ray diffraction, which is a very powerful tool to just to do the not only the elemental analysis, but the phase analysis, and in this way to find out what kind of a material can be included in a certain pigment. So in this particular picture, the main questions, which is in National Museum in Krakow, the question was about the blue color, which is on the left-hand side. So there were, since we already know what can be included in blue paintings, so the question was to discriminate between 5 different or 4 different possibilities, which was done by XRD analysis of the spot, in which my colleagues are experts. And 2 different materials were found out as present in this blue spot in the picture. So the question was answered. Another question, there are numerous examples. I'm just taking some examples that were analyzed within some kind of a project concerning the collections of the museum in Krakow. Here you have another example, another analysis done by XRD, and another conclusions of the compounds that are present in a picture. Another example is connected with archaeology. In one of the spots in Poland, a lot of different jewelry and coins was found, and well, just to be able to ascertain the time, the period they were produced, well, the ingredients that are there, which also help to find the age. Also, this method of X-ray diffraction was used. And the ingredients, well, the samples were collected very carefully and described very carefully, and the ingredients were found, and the reasons of the degradation also. So in here you have just the ingredients found by scanning electron microscope, which edge analyzing detector, edge energy detector, which is able to do elemental analysis and assign the composition of the coins. And here you have the same samples analyzed by X-ray diffraction, which not only show the elements included, but also the possible compounds. Generally speaking, chemistry did a lot of systematics for painters and conservators, and now it's commonly known that different pigments are simply certain chemical compounds which absorb light in the visual range of waves. Another example, so this was the work by my colleagues, the XRD usage to find the composition of paintings and of archaeological objects to know what they composed of. Another example from my area is the degradation of paper, where I can show you how methods, analytical methods, well, of course, in a very short way, can be used to find out the reasons for paper degradation and finally to establish paper condition. Everything was due to the fact that libraries' collections in, well, like 10 or 20 years ago were undergoing a vast deterioration, which is even called a fire in libraries. This could be noted as a yellowing, total degradation of paper, even described by a famous Polish, the Nobel Prize winner Stanisław Lem in his famous book, Memoriam found in bus tube. So the process of deterioration of paper was even noted by a Polish writer. And this problem was connected with about 80% of the libraries in the whole world. So we ask ourselves a question: why the paper was undergoing such a fast degradation. The reason for it was a new technology of paper making, which was introduced into the paper industry in the mid 19th century. And this change in the technology of paper making was equally important as the Gutenberg innovation and the print technology development. From that time, the books were printed on a groundwood paper, which was not that firm as the linen wood or the cotton or the linen fibers or cotton fibers, which were used to produce old prints. So the problem, in fact, doesn't concern old prints, but the book, moderately modern books printed starting from the mid-19th century. So the question states, why the paper was undergoing such a fast deterioration? Well, one reason we know, this was a low quality material used to produce this, and due to this fact, the printing had become that time so popular, and the books started to be available for everybody and affordable. But this doesn't explain everything. So the new technology needed alum as the additional ingredient into paper mass, added to paper mass, to be able to cover it with a resin. And resin was necessary, such a low quality paper couldn't be printed easily, and no inks, no printing could stick into such a low quality paper. So then resin was necessary to cover it. And to change the surface, the chemistry of the surface of paper, alum was necessary. Alum is just a salt. It's aluminum potassium sulfate. And we now know, and that time, well, the chemists, that time we could talk about the beginning of the modern chemistry, also know that such salts are acidic and introduce acidity into paper. And when we think of acidity, I'll show you here, we can consider the mechanism of acidic hydrolysis of glycosidic bonds, which is the main reason for paper deterioration. So another question which appeared in mind, so how to prevent such a acidic hydrolysis, where acid plays a role as a catalyst for this process of glycosidic bonds cleavage. Well, if something is acidic, why can't we add some basic agents to higher the pH of paper, as we may put it? So on this, the whole method of books preservation was based on this presumption. We also were able to ascertain that paper degradation was also due to oxidation, which is another main pathway of degradation. And this is, has been described before by the so-called Bollanchi mechanism of oxidation of polymers due to hyperoxide production in the material. So we were using mainly infrared techniques and Raman techniques, which were performed in situ. In situ means that the samples were put into the reactors, small reactors, equipped with some windows which through which the light could go. And in this way, we were able to oversee what is going during the in situ, well, the real-time degradation in paper materials. So we did it in the precisely chosen conditions, dry conditions, wet conditions, where we had some water vapor, and we were trying to see what is going on in paper. And what you see in here are just the carbonylic group development of different kinds, because we can when we think of carbon groups, we think of aldehydes, we think of carboxylic acids, we think of ketones. So these are just different, but all of those are simply the products not only of oxidation, but also of cellulose hydrolysis. So through this, we can think of a model of paper and cellulose degradation. So thanks to the efforts of different scientists, I must say in the word, the technology for paper deacidification was developed and introduced even in Krakow in form of what we call paper clinic, which uses magnesium oxide to introduce as an alkaline, firstly to deacidify paper, and secondly to introduce some alkaline reserve into paper. And you see in these pictures how the books are maintained, and well, the reactors in which they are stored for some time are shown, for example, in here. And in such chemical reactors, the books undergo deacidification in the solvent that is containing magnesium hydroxide and magnesium oxide. The examples of the use of modern analytical techniques into well, analysis of artifacts and paintings are just numerous, now just I may say endless. And only here there is a famous painting by Munch, as I see, analyzed by my friend Constata Milani from Perugia, who also is using infrared methods to analyze the composition of the paintings. So just to conclude, I may say that the clue is synergy. So I think that both ways art can inspire and increase creativity in scientists and inspire them. And the other way around, science can do a lot of for inspiration of artists, and in particular can aid artists to choose proper materials so that they can be durable, they don't deteriorate fast, and heritage sites also help to prevent or to repair artifacts and prevent them from further deterioration, to keep them for future generation. Thank you so much for your attention. I hope that you will find this lecture interesting. Just our approach to combine and to glue together something which was separated before to find another surplus value in it. Thank you.